Hello everyone, we're going to be using S Foundation to design this foundation using ACI 440 provisions and GFRP reinforcement. So we've defined this foundation already. It's given deliberately small section size or dimensions. We also have some reinforcement, which is currently set up as steel reinforcement, but we're going to adjust that. So just for a little bit of an introduction here, we've got about a 1300 millimeter pad size. And we're going to go here to the load combinations, which have already been defined. So we have an SLS load combination and a ULS load combination. And the reaction load in ULS is just 1500 kilonewtons of compression. And for the SLS load combination, it's a little bit more. And we also have the sustained service load factor of 0.6, which is the ratio of resulting demand bending moments in the pad as a sustained portion of the design load for the GFRP creep rupture requirements and checks. We're going to look at the rebar. Right now we have the Canadian bar sizes, but I'm just going to clear that out. And I'm going to go to the GFRP option and add that in. We can obviously define our own bar sizes as well, but we're going to use these GFRP bar sizes for now. And in the design input window, we're also going to change the concrete code. Currently I'm using the ACI 440.11-22. I'm going to change this to the ACI 440.11-22 code. I've just toggled on the ability to run additional checks, and I'm going to go ahead and run the analysis and code check, and we skipped ahead to the results, and we can see here we're getting a high utilization ratio. This is showing us our governing utilization is governed by GFRP creep rupture, and it's very high utilizations. But this is all based on the fact that I've deliberately assigned a small foundation size with relatively large loads. So this was by design because I want to show you some of the design functionality that we have in S Foundation. So again, as a reminder here, we can see the dimensions. It's a 1200 millimeter by 1200 millimeter pad with 250 millimeter thickness. We can see the amount of steel we have in the pad as well. And I'm going to go to the Run menu and take advantage of some of these design wizards, which are Python scripts behind the scenes, so they can always be modified and even expanded upon. We're going to start with the wizard to design our pads to soil bearing. So it's going to change the dimensions of the pad with 100 millimeter increments, and I'm just going to click OK to show what's happening here. It's basically expanding that pad area until we satisfy the punching shear demands for allowable soil bearing capacity. So it went from a 1200 millimeter width to a 2300 millimeter width. And the next design wizard is to design our pedestals. So it's a similar approach. We have a width increment and a depth increment, and we're going to increment automatically using that wizard until we come up with a satisfactory design. Then we'll look at punching shear, where we're going to increment the thickness of the pad with 50 millimeter increments. And we're going to iterate through this approach, again, automatically using this wizard. So due to the high compressive loads that we have, we end up needing to increase that thickness quite a bit, but we're now at a point where that one is working. We can do the same thing for one-way shear and flexure. I'm going to jump right to flexure here. And what it's going to look at now is adjusting the reinforcement spacing. So the bar sizes and the reinforcement spacing can be adjusted. And you can see here it's come up with, for flexure, a utilization ratio much less than 1 for this example. Now I'm going to go ahead and run all the code checks all at once just to show that they're all passing. And we can see here now our utilizations are all less than 1, just barely less than 1 for soil bearing. But again, that can be further modified manually if we wanted to. So we can see everything now is in a passing state, and we could technically proceed with this design. Plus we get all the details of this design. So I'm looking here at the GFRP creep rupture checks, and I can see the details that went into that as well.